Welcome to Careless Coder, and today we will be traveling to the DOS star cluster. Make it so, number one. Engage. Motherfucker! So today we're going to program a Starfield in DOS using assembler. It's a nice little program, and it's actually a screensaver that I have written in 89 or 90, and I found it last year on a floppy when I was throwing stuff out. I was like, ah yeah, I remember working on this screensaver. I don't think whether I actually ever finished it and made it Terminator stay resident, but it is a Starfield with parallax scrolling. So let's jump in and have some retro coding fun for DOScember.
We're going to set a few constants. So first T-stars, that is the total number of stars, 250. Then the vertical retrace, which is bit 8. And then the input status register, that is the port number for the VGA input state register, that we're going to use to actually sync everything to the vertical retrace. I didn't do that when I initially wrote this program in 1990 or 89. And when I recently ran it on this 486, it was too fast. The variable PARN will contain a random seed value that we're going to use. We're going to generate the star position pseudo-randomly. And then we also need an array for the star field. And that is basically 3 bytes. We have the offset in screen RAM, which is 2 bytes, basically in X and a Y you could say. And then the color, so 3 times the T-stars amount. And since we do not know what we're going to initialize in it, I will call it dub with question mark. Now the code block, and of course we need to start from 100 hex, because this is a DOS program. And let's create a main proc and a main end. And now we're going to initialize the screen mode to MCGA mode, which basically means that every pixel is 1 byte. So we just have to set the color in a certain offset, and that draws a pixel. And that is mode 13, and we call interrupt 10 to set that mode. And that's it. And that screen memory that starts at A000 we will put onto the extra segment. And A000 is the screen memory for the MCGA mode. So basically all the stars that we see on the screen are in the extra segment, and the extra segment is mapped to A000 hex. And the T-stars array, which basically is a word and a byte structure, and then 250 times, we will put on the data segment. And it's not max, it's move. Now let's see if this boilerplate actually compiles. It will crash horribly, because we will probably run into other code, but at least we will see that it compiles, and that's important. And of course we need to have an EndMain. I always forget that for some reason. And I also mistype it. There we go. I'm still using that bbatch file to build the exe. And yes, it starts and it goes to that nice graphics mode. Cool. So now we will create the seed random procedure that will actually set a random value in the PRN, and that is based on the timer value of the current timer. So we first clear out AX. This is the fastest way to set a register to 0. And then we call 1AH interrupt, and that reads actually the timer. And we put that value that is then set in DX into PRN. Basically generating a pseudo-random value, a seed that we could actually seed everything with. For now we're going to call that only once in the initialization phase, but later on I will actually move this within the random function. Talking about the random function, let's implement the random function. Like I said, I decided to call the random seed within this function, so you do not need to call it separately. And this random function is a linear congruential generator. Something that you can find on the internet or in your computer science books, and it basically just multiplies certain magical numbers together and then reuses those results as a seed for the next one. I sort of tweaked it here to fit my own purpose. So now I will multiply this LCG multiplier with our PRN random seed. I'm not a fan of using the multiply because it's relatively slow, but it's fast enough in our case. And then we add a special offset to it, the 13849, which generates this nice little pseudo-random number. And we're going to store that in PRN so that it basically feeds back on itself. And now that we have a random function, we can generate our LoadStars procedure, which will load stars on a random location in screen memory and set that color there. So for each star, we need to randomize the location. So I use DI for the star offset and David Niven, that was a good actor. But BX will point to the stars array. That's so funny, I try to put down a semicolon and I put down an L. My God, I suck. So the first random value that we generate will be the color of the pixel. And we will range that in between the values 15, hence the end AL15, and 30. That's why we add 15 to it. So the color will be between 15 and 30. Or actually I should say the luminance. It's not really the color, it's the luminance of the value of the pixel. It's only white. And we offset it by 2 bytes because the first 2 bytes is the position of the pixel within the memory map, which is a 16-bit value. And then we add 3 to BX, so it points to the next star structure in the stars array. And just for clarity, that star structure has 2 bytes for the offset in screen memory and 1 byte for the color. Now we will create a random value for the XY position or the offset in the screen memory. So we call random again, and then we have the random value in AX and we move that to BX. And then of course we need to call random again for the color. So now we should have a color that is random and a position within screen memory that is random. And we should repeat that for every star. So we decrement the DI. And as long as DI is not 0, we still have stars to assign a random position and a random color. And otherwise we would just return. So all this does, for each star it will generate a random screen memory position and a random color. Now during the initialization we can call the LoadStars, which will set the random position of the stars and the random colors. I did notice a typo, there should be a colon there, and I like my labels to start at the beginning. Writing code while explaining it, it's not easy. So now we are ready to implement the DrawStars function. This DrawStars method is very simple. All it does, it takes the offset from a star, finds that in the screen memory, and then takes the color of that star and sets that in the screen memory. So basically just toggling a memory position in screen memory to a certain color. And in doing so, basically setting a pixel to a certain color. That's all it does. And it does that for each of the stars in the stars array. Seriously, what is up with me and Niv? Is it some Freudian closeted homosexual desire to shag an old guy? I don't know. It's worrying though. There is seriously something wrong with me. Niv. Okay, in AL I will store the color from the stars. And in BX, of course, the memory offset for the pixel that we're going to change the color of. And then we're going to set that value, BX, in the extra segment to which the screen memory is pointing with the value AL, which is the color. Basically turning that pixel that BX points to that color that AL points to. And we will add 3 to BX because each star structure is 3 bytes long. And then we decrement DI for each of the stars that is already painted. As long as DI is not 0, then there are still stars in the stars array to be drawn to the screen. Eventually, when it is 0, we have drawn a maximum of 250 stars to the screen. So now we can call the DrawStars routine in our main. And for now we will just loop infinitely to see whether it works. We want this to work before moving on, it's very important. Now do we see some different Luminance Stars? And there it is. Oh, that looks nice. Yeah. Star Trek, baby. Now first let's implement the key press exit function. In the previous video with the raster bars, I used a shared library that I created that has this function, but here I just write it out, and that way you also have seen how it works. So the key P function looks something like this. So we set up an interrupt 21 with AH with the value 6 and DL with the value 0. That will read the keyboard matrix without blocking. And when a key is pressed, it will be set in AL. As long as it's not set, it will be 0. So as soon as a key is pressed, AL will no longer be 0. And then we will jump to exit and we will call the interrupt 24C exit call. And otherwise, we just return. So when a key is pressed, we need to reset the screen to text mode. So we set AX with 3. 3 is the text screen mode, and we call interrupt 10. And after that, we exit to DOS by setting AX to 4C00, AH with 4C, which is the exit, and the AL00, which is the exit code, which is 0 in that case. And then we call interrupt 21 and we're exited cleanly. So now we call the key P function, and that way when we press the keyboard it will exit cleanly. Now let's create an infinite loop that allows us to move the stars and display the stars. And actually this is a typo. Later on I will create an underscore loop because loop is a registered word. Here I'm calling the third retrace, which we have not yet implemented, I realized. We do that later on. And then we call the MoveStars. We're now going to implement the MoveStars, which will basically just take the loaded stars and move them an X amount of pixels. This MoveStars procedure is the most difficult procedure of this application. But basically what it does is it sets the star currently visible on the screen to black by setting it to 0, and it moves the stars by subtracting a certain amount depending on their brightness. Brighter stars move faster to the left than darker stars. The distance that each pixel travels to the left is based on their luminance. So if the luminance is 15, it will move 4 or 5 pixels. If the luminance is only 10, it will only move 1 pixel. And that's basically what we're going to do here. But first we need to blank out the previous drawn pixel with black. So obviously we are again going to loop through the stars struct using the DI and the SI index registers. And this is how we set the previous pixel drawn on the screen to black. Basically erasing it from the screen. Here I obtain the pixel color from the stars struct. So AL contains a value between 15 and 30. For ease of use, I will subtract 15 from it, which makes more sense when you read the code that you realize that it's the luminance value. So here I'm implementing basically a switch statement. Every time that it is below a value, JB, jump below, we will jump to slow, basically stopping to decrement BX. If it's above, we decrement it and basically speeding up the brighter pixels, slowing down the darker pixels. So 10 is only decremented once, 11 is decremented twice, 12 is decremented 3 times, and 13 is decremented 4 times. And 15 is decremented 5 times, basically moving 5 times as fast. And we need to run that switch statement for each pixel. So we offset SI by 3 because the vector once again is 3 bytes, 2 bytes for the memory offset and 1 byte for the color. So as long as it's not 0 or DI is not 0, then we just continue to move. So now I need to re-implement the vert retrace. I forgot that. And it's the same like we did last week with the raster bars. Exactly the same. So what we will do is we will read the input status register and mask it with the value 8, the vertical retrace. As long as it's not 0, we will wait. And then as long as it is 1, we will wait, and then we have had a vertical retrace. So here CLI will disable the interrupts. We don't want any interrupts whilst we're waiting. So here we're reading that port in DX from the input status, and we will mask AL with our vertical retrace 8. That's this end statement. I really need a typing course, don't I? Unbelievable. And as long as that's not 0, we wait. Now at a certain point, it will no longer be 0. And then we need to wait until it goes back to 0. Because it's not 0 when it's actually in the process of retracing back. And then we need to enable interrupts again, otherwise also our keyboard press wouldn't probably work. And this should be it. Let's compile it. And there is an error. There is always an error. I like MoveStars better than MoveStars, so I will rename the function because we're moving all the stars and not a star. Let's recompile. And there are still errors. Oh my god. And I think I know what it is. I may have typed deck wrong. Sure enough, yes, it's Dex. I knew it. And now it should work. Last famous words. Ah, look at that. Yes. Now we have some pixels that are not really nicely randomized. And I think that's because we do not wait long enough between actually seeding the random generator. So let's fix that. Let's simply wait a certain amount of time for a tick to roll over. So the easiest way, and that's what we're going to do, is basically slow down the random process. We just load a CX with 9FF, and we just decrement it until it's 0, and then we generate a random number. That way there is enough time for the CPU timers to roll over to a different number, and we get probably a better random seed. And we call this slow seed. My dad had slow seed, and that's where I came from. I was the fastest. That's hard to believe, isn't it? This is not working, is it? I think I may have screwed up. Big time. Let's see. Oh, come on. That is a rookie mistake. Having the move CX with the value inside of the decrement loop. I need a different job, don't you think? If you got a different job, then contact me. And here we go, an error. Oh yeah, stars. No, it's sky. Yes, you saw the little wait, and it's now more randomized. Now this is really cool, this looks really nice. Because the brighter pixels move faster than the slower pixels. And another random seed, yeah, it's cool. So we sort of have a little parallax. Look at that. And the reason I did this with the brighter pixels moving faster was not necessarily a parallax effect, but on my phosphor screen, they didn't show up that well. And so I had to boost up the luminance of these brighter pixels. This actually was a screensaver that I created in 89 or 90. I used to have a screensaver with a Starfield, but all the stars would race across on the same lines, basically creating burn-in. And that's not the intention of a screensaver. So I figured, what can I do? I like this screensaver, and I came up with this solution. Basically, every pixel here starts drawing from the right to the left and then from bottom to top. So the screen is exposed the same amount all over the screen. So there is no chance of actually burn-in. There is equal wear on the phosphor. So yeah, it's kind of cool. And I don't recall whether I had a terminate and stay resident in this program, because I couldn't find it on that floppy. Maybe it's one of those abandoned projects, I don't recall, or it was wrapped in a TSR application. I recall making one that could start different applications, but yeah, it is a screensaver and it's kind of cool. Now let's see how it looks on the real hardware. And we can reseed it by running it again, and we have a different pattern. So there you have it. I'm holding a DOS star cluster in my hands. And that is possible because it's called Microsoft DOS. Not Galaxy Soft DOS or Macro Soft DOS, but Microsoft. And it was fun revisiting this project after more than 30 years. It's unbelievable how the time has flown. And it's still so much fun working with these old machines. So I hope you learned something, and I'll see you in the next one.